So in this question we use the property that length of any side has to be less than sum of other two. So what is perimeter of the isosceles triangle? So we need the three sides of the triangle. First statement says one side is 9, clearly not sufficient. The other one says one side is 4, clearly not sufficient. We don't know anything about the other two sides. Combining it, we know one side is 9, another is 4, and it's isosceles, so one number repeats. So it could be 994 also, it could be 449 also. But if you see, this condition has to be satisfied for any triangle. The 9 is greater than sum of other two. So this is not a possible case, this is invalid. So only one case is possible, 994, sufficient. C would be our answer. At the statement second B, that the length is 5. So after combination 995 and 559, both would be possible, both would be valid, because sum is bigger than the third side. So in this case even C would be not sufficient, then A would be the answer. So the question says x is equal to 3, and again what is the perimeter? First statement, the sides are consecutive integers, so it could be 1 2 3, 2 3 4, or 3 4 5. But if you see, in this case 3 is equal to 1 plus 2. Okay, length of one side is equal to sum of other two. It cannot happen, but still two options are possible. Not sufficient. Second one says it's not a right angle triangle. So not a right angle triangle means it could be anything actually. There could be infinite possibilities. So this alone is not sufficient. If we combine the two, and if you see 3 4 5 is a right angle triangle. Okay, now if we combine the two, that means both the statements must be satisfied. Only one, which is 2 3 4, will satisfy both the statements. So this would be sufficient. C would be the answer. Again 6 and 9 are two sides. So 6 plus 9 is 15. So the third side has to be less than 15. Okay, because if it is 15 or more, it will violate the condition that length of any side has to be less than sum of other two. Again, if 3 is one of the sides, then 3 plus 6 will become equal to 9. But 9 should be less than sum of other two. That means this side should be anything more than 3. So the third side should be between 3 and 15. 13.5 is the only possibility. So in this question, first of all, the property used is if we have diameter and we have any point on the circumference, so the diameter will make a 90-degree angle with that point. So that's the property we'll use here. This angle is 90. So the first statement says CD is equal to twice of BD. So let's say CD is 2x and BD is x. So BC will become root 3x by Pythagoras. So 1 is to root 3 is to 2 is the ratio of the sides, and this happens when the angles are 90, 60, 30. So all the angles are known to me, sufficient. Second says y is equal to 60. So if this is 90, this is 60, this would be 30. This is also sufficient. D is your answer. And this is the trick question. Why? The side AB looks like diameter, but is it given in the question that it's the diameter? No. So we cannot assume. Okay, so AB looks like diameter, angle C looks like a 90-degree angle. No, but we can't assume. Okay. So what is area of the triangle? That's the question. So area would be half base into height So half into BC into AC. So if we can find BC and AC, we can find area. First statement, angle ABC measures, this measures 30, but we have no idea about the other two angles. Okay, so in no way we can find other two sides. It's clearly not sufficient. Second, circumference is 18 pi, circumference is 2 pi r. So radius becomes 18, so radius becomes 9, dia becomes 18. So from here what we know is that AB's diameter, because it's 18, so this angle would be 90. We have no idea about the other two angles. So again we cannot find these two sides, not sufficient. If we combine the two, so this is the triangle. First statement says this is 90. Second statement says this is 90 and first says this is 30. So this becomes 60, 90, 60, 30. Ratio of sides is 1 is to root 3 is to 2. So one side is known, which is 18. We can find the other two. This would be 9, this will be 9 root 3, but we don't need to find it. So we can find it, we can find the area. C is sufficient. In this question we need to find perimeter, which is this shaded portion. So one of them is arc, the circular portion, another is straight line. Now if we draw this figure again, so this is diameter AB and this is BC, this is CD, this angle is 30. Now since CD is given parallel to AB, this angle becomes 30 and this is also equal, this is 30. So BC will be equal to BE. Okay, both these lines will be equal, so we just need to find one of them. Now remember, whenever we have a circle, angle within a semicircle is 90. This property is very frequently used. So if this is 90, this is 30, this becomes 60. So 1 is to root 3 is to 2 will be the ratio of the sides for this triangle ABC. AB, which is the hypotenuse, is given as the diameter, which is 10. This becomes 10, this becomes 5, this becomes 5 root 3. Opposite 60 is 5 root 3. It's 5 root 3, this will also be 5 root 3. So BC plus BE is equal to 10 root 3. Okay, so the sum of two straight lines is 10 root 3. Now we need to find out this arc. Now whenever we find arc length, so what we need is angle it will make with the center, this theta. Okay, so the arc length becomes this theta upon 360 into 2 pi r. Now there is one property which says if the arc makes an angle theta with the center, it will make half of it theta by 2 at any other point on the circumference. So if you see this figure, this arc makes an angle of 60 with this point. So angle at the center will be double of that, 120. So theta becomes 120, 2 pi r. R is 5, so this becomes 10 by 3 pi. Okay, so 10 root 3 plus 10 by 3 pi, D is your answer. Now this is a really good question. Area is half base into height. Okay, First statement says AC is equal to 6. Let me take AC, this base, as 6. Now this being 6, BC can be anything, like BC can be 1 also, and BC can be 100 also. I mean, it can take any value irrespective of what this value is. So in this case, if you see, area will be less than 25. In this case, area will be more than 25. So first statement clearly is not sufficient. Second statement says AB is equal to 10. So the hypotenuse is equal to 10. Now what happens when hypotenuse is 10? Since hypotenuse is the largest side in the triangle, the other two sides have to be less than 10. Okay, now let me take one simple question. Perimeter of a triangle is 30. What is the maximum possible area of the triangle? Okay, we are not talking about just area, but maximum possible area. So there is a rule which says area is maximum when symmetry is maximum. Okay, the figure becomes as symmetrical as possible. In that case, the area would be maximum. So the symmetry maximum can become for a triangle when it is equilateral triangle. So perimeter is 30, so all sides equal 10, 10, 10. We can calculate area in this case. That will be the maximum area. But here we have a right angle triangle that's given in the question. So it cannot become equilateral. The maximum symmetry we can have is this being isosceles. That means these two sides are equal. So these angles become 45, 45. So this is 10 by root 2. This is 10 by root 2. So area in this case will be maximum, will become half base into height, that is 25. Question is the area bigger than 25? The statement says maximum area is 25. So area can't be more than 25. Confirmed no. This is sufficient. B will be the answer here. ABCD is a square. So the area is 625, the side length is going to be 25. Now the rhombus. Area of the rhombus can be calculated as base into height because it's a parallelogram in first place. So base into height can be used to find area. This is given as 500. So base, I can take it as 25, so the height must be 20. Now if you see here, this red line would be the height 20 and this would be perpendicular. So it becomes a right angle triangle. This becomes 25, 20. So if you use Pythagoras, this would be 15, this part. So this area will be 500, half base into height, which is 150. So this will become 500 minus 150 equal to 350, and this will become 625 minus 350, which is 275. That would be your answer. Area of a trapezium is given as half sum of parallel sides into height. Okay, area of triangle is given as half base into height. In this question, if you drop a perpendicular from point D to AB, this let's call it F. DF will be height for both triangle as well as trapezium. So area of the trapezium would be, or area of the triangle would be half. I can take AB as base into height upon area of the trapezium will be half AB plus CE, sum of the parallel sides, into height. So the ratio would be nothing but 6 upon 6 plus 18, 1 upon 4. Now this is a really good question. First of all, drop a perpendicular or join E and C. Okay. So now if we take a rectangle like this, okay, that's a length into width is area. Now if I draw a triangle by taking a random point on this side, okay, this point is a random point on the side. So this is the triangle I've made. Okay. For example, this point C is a random point on this side GF. So this triangle DEC is like this triangle here. Okay. Area of this triangle, half base into height. So base can be taken as L. Now height will be nothing but W. So area of the triangle is equal to half area of the rectangle. Same case would be here. Area of the triangle DEC will be half area of the triangle, area of the rectangle DEFG. Okay. Same way, if we take rhombus, sorry, this parallelogram DABC, okay, ABCD, area of the parallelogram would be base into height. So I can take this as base. So height would be this perpendicular to both AB as well as, this perpendicular, let's say this would be height, okay, which is AH. Okay. Now area of the triangle, which is DEC, half. Now base of the triangle can be taken as this base, and height would be this same, the height that was taken for the parallelogram, right? So area of the triangle DEC is half of area of the parallelogram also. It's half of the rectangle, half of the parallelogram, so parallelogram area is equal to area of the rectangle. First statement is sufficient. Second tells me altitude, this AH, it gives me nothing, this is not sufficient.